Okay, now let's talk about Curie's law. All right. See, when we talk about Curie's law or Curie's temperature, so how we define this is it is the temperature above which a ferromagnetic substance loses the property of magnetism without an external field in it. Okay, meaning in other words, so very easy to understand is, suppose let's say you have a magnetic substance, a magnet. You heat it, it loses its magnetic property. Okay, so this temperature is what we call as Curie's temperature. All right, now how we can explain this is, let's say you have metal, so every metal has atoms which are aligned in some direction, correct? So in a ferromagnetic substance, all the atoms will be aligned in one direction. Fine. So you give temperature, meaning you're giving energy to those atoms. The atoms will start moving in different directions. Okay. So once they start moving in different directions, that's because of the agitation which is caused. Okay. As they start moving in different directions, so what happens? It loses its magnetic moment. Okay. Once it loses its magnetic moment, the magnetic property will come down. All right. So above the temperature, the ferromagnetic substance loses its magnetic property. Okay. Now, how we use this is there is something called as magneto-optic storage devices. Okay. So this is something where, so you have magnetic tapes and magnetic discs. All right. So we erase those things by using heat. Okay. So we take laser, we erase the information which is stored in the disk or tape, and then again we can store it back. Okay, so this is how these temperatures are used. All right, so now see, what we have is every metal has certain temperature. Okay, like for iron it is somewhere close to 770 degrees Celsius or around 1000 something Kelvin. Okay, 1000 odd, close to it. So different metals has different Curie temperature. Now this 770 degrees Celsius, what we are talking about, that we can find around 20 kilometers inside the earth. Okay, if you dig 20 kilometers, the temperature is around 770 degrees Celsius. So meaning iron loses its ferromagnetic property at 20 kilometers under the crust. Now the temperature around the earth's core, I'm talking about the upper core, it is somewhere close to 2000 to 2500 degrees Celsius. It's way above Curie point, correct? Or the Curie temperature. So iron can never be a ferromagnet at that temperature. So we can prove that Earth's core is not a magnet, right? But still, there were a lot of discussions about Earth's magnetic field, correct? We also discussed about it. So Curie's temperature plays a very vital point in figuring out whether the material, whatever you have, above which will it be a ferromagnet or below it which will be a ferromagnet. Okay, this is very much used in industries. All right, so now look at the table. So these are certain Curie temperatures for different metals. Okay,